Good morning. This is the lesson over conic sections. So the first conic section that we're going to talk about is a parabola. So when you're looking at a parabola, it's really a set of points in a plane that are the same distance from a given point called a foci, and a line called a directrix. So if you look here, we have this orange line is our directrix, and this point here is our focus. Okay, we have an axis of symmetry. We have a latus rectum, that is the line that connects the 2 points on the parabola that are equidistant then from your focus. It's perpendicular to your axis of symmetry. So what we need to do is to be able to look at our different equations. So we have what we call vertex form, which this book actually calls standard form. It's the y equals a x minus h quantity squared plus k. We have our axis of symmetry focus. It shows you here how to find your focus. It's h comma, and then it's k plus 1/4 of your a value. So then your directrix, your directrix is y equals k minus 1/4 a. And then your opening, if your a is positive, your parabola opens up. If it's negative, it opens down. And then it tells you how to figure out how long the latus rectum is. So notice that that is given it to you when it's a y equals, but we have the same idea when it's an x equals. So this is important information that you might need. Another one is a circle. This section really doesn't focus a whole lot on circles. Your h and k are your center, your r is your radius. So that's the standard equation for a circle. Then you have your ellipse. Okay. With an ellipse, you have a major axis and a minor axis. The major axis is the axis where, if you think about it, it's stretched longer. And your minor axis is the shorter side of that ellipse. You do have 2 focus points. Then here is your information that you would need here. How do you find your foci? Your foci are your h plus c, comma k, and h minus c, comma k. So they will fall along your major axis. So here is your general equation. If you think back, it looks kind of like the equation of a circle. Notice you're dividing by an a squared and b squared, which will be constants. It does give you some additional information here. Notice that c equals the square root of a squared plus or minus b squared. Okay, so that's how you find that value of c. If a squared will always be bigger than b squared. So if your a squared is under your x value, then that x, or your horizontal, is your major axis. If your a squared, which is the bigger value, is under the y, or the y squared, then the vertical axis is your major axis. So that's something to look for as you're looking at the equation of an ellipse. So then you have a hyperbola. Again, you notice that you'll see you have some black lines here. They're actually not part of your hyperbola. The hyperbola is what is in blue. And you have 2 focus points. You have a center, which in this case is at the origin, and you do have a vertex on each side. So what do these equations look like? Very similar to what you just saw, but it's a minus in the middle instead of a plus. Again, we give equations of how to find the foci, the equation of that asymptote. So if you notice, it has the asymptote going both directions. Those are the diagonal lines that it's getting really close to. How to find your vertex, and what is your transverse axis. So is it horizontal or vertical? And that kind of is controlled again by which value has the highest. Is it your x squared or your y squared that has the highest value underneath? If you have any additional questions, please make sure that you send me an email, and have a great day.